Welcome to our channel. Picture an outdoor cannabis garden at the peak of summer, vibrant, lush, and operating at its full metabolic limit. When ambient temperatures cross 30 degrees Celsius, about 86 degrees Fahrenheit, that growth stops. The plant shifts from building biomass into survival mode. You'll see the warning signs on the leaves first. The margins begin curling upward, taking on a tight canoe-like appearance. If the heat persists, the top of the canopy starts to bleach. Necrotic spots appear, and the dense flowers mutate into airy, spire-like structures, known as foxtails. The plant is starving to death in plain sight, yet the soil is likely full of nutrients. A lack of food in the ground is unrelated to what is killing this crop. The plant's own biological defenses are triggering its destruction. Saving the harvest requires tricking the plant's internal biology. Let's look at the microscopic surface of a leaf enduring extreme solar radiation. These pores are called stomata. To prevent rapid moisture loss during a heat wave, they slam shut to trap water vapor inside. While this preserves water, it halts carbon dioxide uptake. The molecules bounce off the outside, unable to penetrate. This is photoinhibition. Without carbon dioxide, the plant cannot perform photosynthesis. It is effectively starving for energy despite being surrounded by light. By prioritizing water retention at the cost of carbon dioxide, the plant chooses to suffocate itself to delay dehydration. The plant activates non-photochemical quenching, or NPQ. It converts excess solar radiation into radiating heat waves to prevent light damage. This drives internal temperatures higher than the air outside. The cell glows red on a thermal scale, cooking from within. When growers see this heat stress, the instinct is often to flood the root zone with water during the peak of the day. But midday watering shocks the roots. If the stomata are already locked shut, the plant cannot uptake that water efficiently anyway. Flooding a suffocating, internally overheating plant is a dangerous response. You are drowning a stressed root system without lowering the temperatures in the canopy. Please like and subscribe. It really helps our channel a lot. Breaking this cycle requires us to step in and externally engineer the outdoor microclimate. The solution is a physical intervention, deploying a 30% knitted shade cloth over the canopy during peak sunlight hours. This woven barrier blocks damaging UV radiation and intercepts excess ambient heat before it reaches the leaves. It still allows 70% of the light used for photosynthesis to pass through. This filtered light is gentle enough to prompt the stomata to safely reopen. By artificially lowering the light intensity, you deactivate the plant's internal heat production. The plant breathes again and stops the internal overheating process. Beyond the physical barrier, we can use nutritional supplements to fortify the plant from the inside out. Potassium silicate acts as cellular armor. It builds a rigid, geometric layer that thickens and stiffens the plant cell walls. This reinforced structure improves stomatal regulation and provides the structural integrity needed to prevent stems from drooping during a heat wave. We combine this with liquid kelp extract. Use a dosage of exactly 5 milliliters per liter, or roughly 1 teaspoon per gallon. The trace minerals in the kelp dramatically increase the plant's overall resilience to drought. By pairing a microclimate tarp with cellular armor, you bypass the July heat bottleneck. You transform a survival crisis into a period of massive growth. Thanks for watching. This content does not constitute medical advice, legal advice, or recommendations for the use, self-treatment, or consumption of any substance.